All right, we are getting started. It is 5 o'clock, I believe. Yes, 5 o'clock, Thursday. And we got Joseph in the house. And we are talking panel boards today. I don't know about you, but it was a pretty busy day today. It's 5 o'clock. And we're talking technical stuff, but man, I don't know about your day. It was full of meetings, and but 70B is over. So NFPA 70B first draft meetings were over yesterday, and I have to catch up on all the phone calls that I needed to get back on, the emails that I'm missing. I'm still not caught up. I don't know about you, but when you're not fully into your day-to-day job, pulled off to the side like on codes and standards work, it things get backed up pretty quick. So hopefully you got your coffee, because we're going to dig into panel boards. And I have think I have everything I need. Let's just talk about make sure I don't screw that up. So today's topic is panel boards. Good evening, everybody. It is April Fool's Day. So I thought about just playing a little video and not having an event and say April Fools, but I didn't do that. Couple items that I want to cover before we get into the program. First off, next Tuesday, remember I go live at 5 every Tuesday and Thursday. Next Tuesday, which is April 6th, I will not be going live on my YouTube channel, nor LinkedIn, nor Facebook, because I will be conducting the West Virginia Chapter International Association of Electrical Inspectors meeting, presentation, CEU course on NFPA 70, the National Electrical Code 2020 code changes. So we're going to be talking about 2020 code changes based on the IAEI, International Association of Electrical Inspectors Analysis of Changes book, which this is the 2020 version. So we are going to have 2 days of going through this book on all of the key changes that occurred in the 2020 code, starting Tuesday morning at 8 o'clock a.m. Eastern, 8 to 10, 2-hour sessions, two 2-hour sessions each day. And we will have CEU certificates for each of those. I, myself, and Mr. Tim McClintock, our NEMA field representative for the Midwestern territory, will be covering the 2020 code changes. I invite you to, now it is a paid function. So, hey, James Smith, we have registration is on the West Virginia chapter's website. Very inexpensive for 8 hours worth of CEU credits from the International Association of Electrical Inspectors. It's $50 for IAEI members and $75 for non-IAEI members. You're not going to beat that price. It's a great, I mean, regardless of the CEU credits, we're going to be going over 2020 code changes, and I'm going to have Mr. Tim McClintock with me, who is absolutely awesome. If you've not experienced one of his educational programs, you're missing it, because he's like Paul Harvey, the rest of the story. He can bring a lot to the table to help us understand why changes were made, and a lot more depth from an application and practical perspective than even I can bring to the table, or most others. So he's I think he's one of my best kept secrets. And I'll share him with you for $50 if you're an IAI member, and $75 if you're not an IAI member, for 8 full hours. And then be mindful too that it will be conducted, it'll be streamed on YouTube. So it'll be a hidden link. So you have to register to get the link, and don't send me an email saying, "Hey, Tom, we're good buds. Remember that foxhole I pulled you out of? Send me the link, please." I'm not going to do it. You're going to get it through when you register and pay for the event. It will send you the links. I'm using Eventbrite. So please check that out. All of that money goes straight to date and time, James, is Tuesday next week, April 6th and 7th. April 6th, 8 o'clock in the morning Eastern to 10. So we're doing 2 hours in the morning and then 2 hours in the afternoon. In fact, let me do this. I'm going to, geez, oh man, hold on. Let me just bring it over here. All right, so I'm just going to search IAEI West Virginia chapter, and I'm going to click on the very first link, IAEI.org, and there it is. Welcome to the West by God Virginia chapter, 2020 education seminars. And here we go. NEC 2020 code changes. I'm going to zoom in for you. I'm going to get me out of the way. Boom. So virtual seminar. So there's the view IAI. Let's see what this is. Okay, so this is so if you want to purchase the book, look at that. The book itself, this very awesome publication, is only $79. That's a steal. So here's the dates. So April 6th, 8 a.m. to 10 a.m. Eastern. Chat and that we'll be going now. Be mindful, please be mindful that, whoops, wrong one. Me on monitor one, me with monitor one. No, that's, oh, no, me PowerPoint. So be mindful that it says chapters 1 and 2, 3, 4, 5, 6, 7, and 8. We'll probably start in chapter 1, article 110. We probably won't hit the definitions, but we'll pepper the definitions in as we go through. Definitions can be kind of dry. I'm just saying, 110, there was a lot of stuff that happened in 110. We're going to be talking about some things today that happened in the 2020 code with regard to panel boards. We'll talk a little bit. I'll bring you up to date on what's going on for 2023 with regard to panel boards, but just be mindful. It's that what Tim and I will do, and we haven't yet, so I got to get with him. We typically say, okay, we'll cover this, we won't cover that. We want to try to bring some really good, important things into your day. Don't forget about that session. And the registration, there's the 50 and 75, and there is the Eventbrite registration. If you complete that, you will be registering for all 4 events with 1 registration. So there's not, you sign up for each. It's $50 IAEI members for all 4 events. And then if you miss the first one, I'm not sure, I don't believe, I'm going to be doing the Mentimeter at the beginning and end to verify that you're there. So I can't do the CEU credits if you watch it later, but you can watch it later. You'll have the links to be able to watch it later. I'm going to leave it up there for a little bit before I take it down, because it is, again, you've paid for that. So I wouldn't want It's copyright information, all that good stuff. It's the International Association of Electrical Inspectors. So you're going to want to. It's a good event. So that's the link. If you don't have an event, if you have an Eventbrite account and you subscribe, when you click on this, you'll have the ability to. There's your tickets, and then you'll access the event. But then up here at the top, like I got my microphone right up there. Up here at the top, let me get me out of the picture. I think this is 2. About this event, I know there's access online. I'm already following them. Yeah, see, I'm logged in as IEI West Virginia. That's why it's not giving me the ability. But you can follow the IAEI, and I think it's something that you might want to do. So anytime, if you follow our West Virginia chapter, anytime that we post a new event, you'll just get notification for it, and you can go up there and register. I have an account up there. You can find me on there as well, and you can register for me. And anytime I post one of my events, all of my events are free. I mean, unless I'm doing it for the IAEI, then obviously I'll be charging for those. But my events are free. I do plan on trying to generate some money for nonprofit organizations in the future. I'm trying to figure out those details. So, hey, Ryan Jackson in the house. Thanks for joining, brother. So anyway, let me just fix something here. So anyway, I will be, you can follow me on Eventbrite anytime I post anything up there. So you never know. So today's topic, panel boards. I think hopefully you get something out of this one, because panel boards, I don't know, I put some links down below, and I went live earlier this morning for the Panelboard marking and application guide from UL. Great reference, free reference for you. And there are other marking guides. There's a circuit breaker marking guide. I believe there's a lighting marking guide. If you do some searching on a product, just say go to your favorite YouTube, or not favorite YouTube, but favorite internet search engine, whatever it would be, and type in the product, and go and after that type in UL marking guide and see what you find. You might be surprised. It's also on their product spec. I think that's what they're calling it these days. So, but in any case, you should check that out. You might be pleasantly surprised at what you see. All right, so just making sure I've got everything set here, and we are going to talk about panel boards. I need to close a couple things down. I've got too many things open. All right, panel boards. Article 100. I've got some of this stuff up here, which I know if you are a great code person, you are sitting in front of your code book, and I know you have the 2020 version, because you would settle for nothing less than the latest and the greatest that NFPA has to offer. And if you go to Article 100 is where you'll find the definitions. And just a heads up, in the future, 2023, all of the definitions will be found in Chapter 1. Alphabetical order, there's not going to be a Part 1 and a Part 2. They're doing away with that. Style manual change. Some people love it. Some people hate it. I am indifferent to it. I've got my Keith Laughlin pen. This special pen. I can't think without my Keith Laughlin pen. He made this, and I don't know if I've told you about it, but it's like a resin, but the blue in this is actual electrical tape. So can't think without my Keith Laughlin pen. Got to have it with me all times. Better than a Mont Blanc. So if you look and think about panel boards are covered in Article 408. And Dot 2 in the 2020 version and earlier is supposed to be, by the style manual, Dot 2 is supposed to be definitions and terms that are used in that article. There are no definitions in Article 408 specific to a panel board, switchboard, or switchgear. In fact, they violated the style manual by making 408.2 other articles, but that's okay. That's what they do. So there's no definitions that you have to worry about in Article 408. You go straight down here to Article 100. Right, Ryan? Jackson? And we look for in the P's for panel board. Now, let's read this definition. A single panel or group of panel units designed for assembly in the form of a single panel. I love it. A single panel or group of panels designed for assembly in the form of a single panel, including buses and automatic overcurrent devices, and equipped with or without switches for the control of light, heat, or power circuits. Designed to be placed in a cabinet or cutout box placed in or against a wall, partition, or other support, and accessible only from the front. Code Panel 9. Now, throughout this great book, we violate that definition of a panel board. And I'm going to tell you, give you some examples. If you have I have the 2017 version in front of me here, but I'm going to try to find an example of where we misuse this term. Excluding panel boards from the same panel board, that's all fine. Each branch circuit similar, at each branch circuit panel board or similar. I'm looking for at each panel board, including the branch circuit panel board, shall be provided to serve not less than the calculated load within each feeder panel board. That's not it. At each feeder panel board within. Okay, there we go. We're getting there. Here we go. First one. I'm looking in Article 215, 215.12. 215.12. Walk with me, if you would, to Article 215, Section 215.12. 215.12, identification for feeders. And the first one, is 215.12C, Charlie, identification of ungrounded conductors. And it says C1 is feeders supplied. 215.12 C1, feeders supplied from more than one nominal voltage system. And then if you look at B, posting of identification means the method utilized for conductors originating within each feeder panel board. Okay, within a panel board. The panel board, we recall the definition of a panel board, does not include the enclosure. So when we say within, text message, when we say within a panel board, which doesn't include the enclosure, I can't land something within a bus structure and an overcurrent device. And that's just one example. If you go through this book and search for everywhere we use the word panel board, you will find multiple places where we'll say within the panel board. But a panel board, what they should say is, and I'm going to reference the marking guide. Okay, so that document, that free panel board marking guide download that I gave you referenced earlier. They actually define, and it's in the standard this way too. So in the UL standard 67 for panel boards, an enclosed panel board. So anytime you are referencing a conductor that originates in a panel board, you should be saying in an enclosed panel board, not in a panel board, because a panel board, again, doesn't include the enclosure. So I can't have something originate in something that doesn't have an enclosure. So inside this book, peppered throughout, is that problem. Now, myself and Palmer, we both found this issue, and I had, he raised the question. He said, "Hey, Tom, take a look at how we're using the term over here." So I was supposed to put some public inputs in, and I totally forgot. But he saved the day on panel 1, and he brought up the fact that we misused this. And so panel 1 did make some changes in Article 110, especially, 110. What am I talking? Yeah, 110. 110.16 is arc flash marking. 110.16 says, is it 110.16? Just swore it was marking shall meet the requirements. So electrical equipment such as switchboard, switchgear, panel boards. Yeah. So electrical equipment such as switchboards, switchgear, panel boards, industrial control panels, meter socket enclosures, etc. And it says you have to mark those. We don't mark a panel board. You mark the enclosure of a panel board, but you don't mark the panel board. No, hey, amen. Amen. You did not miss a lot, buddy. We just started panel boards, and we're on the definition, trying to help people understand that a panel board does not include the enclosure. Ryan Jackson was in the house. Nihad El Sharif likes the tie. Thanks. Hey, Nihad, I got another person for our IEEE paper on AFCIs. Send me a note. We're going to get Dr. Well, you'll know him when I give you his name. So anyway, all right. So throughout the book, we misuse that term. So what I'd love to see people start to do is start saying enclosed panel board when they really mean the enclosed panel board. There are times though, like if I say install the circuit breaker on the panel board, it wouldn't be in the panel board. It would be on the panel board because that's the bus structure. If I want to use the word in, I would say in the enclosed panel board. So start using that and just be a little bit more accurate with that regard. And I would appreciate that, as I know Palmer Heckman would appreciate that, and a few others. So in any case, enclosed panel board in the UL standard and in the marking guide says an assembly of buses and connections, overcurrent devices, and control apparatus with or without switches or other equipment installed in a suitable cabinet, cutout box, or enclosure suitable for a panel board application. Yes, you're right. The definition of a panel board includes the overcurrent protective devices. That is correct. Cool beans. I'm trying to see what else. Yeah. So, and then I can now, and here's another reason why it's important to understand this. There are products that you can buy that you're buying a panel board, but you buy it and there's no enclosure because it's anticipated that you're going to install it in an enclosure. So for the most part, we sell panel boards that will include the whole picture. So what is it before we install any breakers? It's still a panel board. When you look at a bus structure, if you look at the definition in Article 100, it says a single panel or group of panel units designed for assembly in the form of a single panel buses, and so it's for assembly of. It's the bus and automatic overcurrent protective devices and equipped with or without switches for the control of lighting, heat, or power circuits. So it's designed to be placed in the cabinet. So if you have a panel board that doesn't have any circuit breakers on it, it's still a panel board. It's not like you have to have circuit breakers or fusible switches in there. It's still a panel board. It's that bus structure. It's an assembled unit. It could be all metal. I've seen them be all metal. I've seen them be a compilation of like a plastic back frame with metal and all this other good stuff. I have to silence this thing because here's what happens. Every time the door opens upstairs, it dings because of our security system. I'm going to put that over there. Get it off my wrist. So the panel board, if there's no circuit breakers on it, doesn't mean it's no longer a panel board. It's still a panel board. And you have a circuit breaker and you would install it on the panel board, but all of that together is a panel board. But it's still a circuit breaker. Okay, that doesn't mean that once you install that breaker on a panel board that now it ceases to, you can't call it a circuit breaker anymore. It's still a circuit breaker. All right. Okay. And then, so those panel boards, I can put panel boards, and we'll show you examples of this a little bit later. I can put panel boards in switchboards. I can assemble these in, I could fabricate my own enclosure and install a panel board in that enclosure. Now, when you start fabricating your own stuff, remember the standards assume that that enclosure you're putting it in is a listed enclosure. And the panel board itself, depending upon the number of circuits, the size of the enclosure is going to matter with regard to bending radiuses and all that other good stuff. So when we start talking about a retrofit panel board, when I say a retrofit panel board, I'm not talking about an enclosed panel board. I'm talking about just those guts, just that panel board itself can be installed in the field within an existing enclosure, but it has to be listed that way, and the enclosure will have to have the right dimensions based upon the size of the panel board that you're going to place in it. And there are rules and restrictions around this so that you follow all of the listings, but we're going to get into that a little bit later. Right now, I want you, the basic fundamental thing that I'm trying to drive home here is that panel board does not include the enclosure. All right. And if you do, please use the term enclosed panel board. So that's a picture of the panel board is this internal unit. Okay. There you'll see that little gray, that gray, those two gray rails are basically the frame, and there's some stabs that come up. All of those slots, or there's actually breakers in there. And the bus that you plug, that it could be you could have a panel board that has we call them a plug-on breaker. It could be a bolt-on breaker. The stabs will determine that. What else? What you're looking at right here is the Canadian version of a panel board, a service entrance panel board, because in Canada they require you to barrier off the entire top portion of the panel board. Okay, so that you don't, and you're not allowed to bring any other conductors other than the service conductors into that compartment at the top of the panel. So you're either going to be pulling all your conductors in from the bottom, all your branch circuits, or the sides. And in Canada, you're allowed to put it on its side, so you can still bring it down through the joists and go through the top and bottom, which would be the left and right side. So, but that's your panel board. Now, the accessories that you're looking at could be the neutral and the grounding bars. Those are accessories that would be installed inside of the enclosed panel board, in the enclosure, mounted on the enclosure, and listed with that solution. So, and you can't modify, so don't start cutting holes in the box and stuff like that. There's punch outs for that, or there's instructions like if the enclosure does not come with knockouts, you're going to be popping your own holes. There's guidance in the instructions to tell you how to do that. Trying to think of what else there is on that one there. So, yep, and then all of your labeling is done on the enclosure, not on the panel board itself. Now, in some cases, you might see some labels put on the panel board itself with regard to telling you what a neutral or telling you where the bonding strap is or things of that nature. That'll be dependent. That'll be vary by manufacturer because of the construction. Not necessarily driven. The standard will tell you that you have to mark certain things. Where they put that marking will depend upon the manufacturer. What else? All right, so that's that. So there's your 408.38 is your enclosure. So 408, remember 408 is the article that we are in. So 408.38. 408.38 says enclosure panel boards, and I'm looking in the 2020 code. Basically, the language that you're going to see in this presentation could be on the 2017, so I'm just going to double check. Panel boards shall be mounted in cabinets, cutout boxes, or identified enclosures and shall be dead front. The exception is panel boards other than of the dead front externally operable type shall be permitted where accessible only by qualified people or persons. So, and the way they use it here, it says, and this is an accurate use of the term panel board, because it says a panel board shall be mounted in cabinets. So that is an accurate use of the term. And it may be, a good public input could be, or I'm going to say a good one. It would be cool to see something that says panel boards shall be mounted in cabinets, and these are enclosed panel boards. To create an enclosed panel board, that'd be kind of cool. To drive that point home. So in any case, the enclosure is, and it's listed differently. Okay, there's a different standard for enclosures than the panel board. So what I've had some people look at the listing mark on a panel board, on a enclosure for a panel board, and they'll look at the listing mark on the enclosure and think that's the listing mark for the panel board, and it's not. That is the listing mark for the enclosure. You've got to look on the panel board, which is that structure in the middle that's mounted in the enclosure, for the listing mark for the panel board. So don't get those two mixed up, because in some cases you might have a company that fabricates their own enclosures and then puts our panel boards inside their enclosure, and their enclosure will be hopefully listed. And so you've got to be mindful of that as an assembly. If you're looking for the listing mark, it'll be on the panel board. Don't mistake what's on the enclosure as that listing mark. So panel boards can have molded case circuit breakers or fuses. Joe Bellantoni. So a load center. No, Joe. A panel board and an enclosed panel board. The term load center is really a marketing term. We do this, our manufacturers do this, and I don't know if I don't know. I'm on the fence. I have a love-hate relationship. I understand the need to identify maybe a product for a specific market. Load center is a term that's not in any standard. It's not in any NEMA documents. It's not. You might find it in an IEEE document just because you probably had some manufacturer. In fact, I fight this battle on some of our. We just had the discussion in 70B. There was a section it said panel boards and load centers, and we removed the term load center because a load center is a panel board. It's listed to the same standard as a panel board. The only difference that I would say is that it's probably prettier than your industrial panel boards. Okay, the cover is probably nicer because it's meant for a residential market. So a panel board or a load center is the marketing term to say this is a panel board that's really designed and meant for a residential application. Can I use a load center in an industrial? I sure can. There's nothing in the National Electrical Code that says a load center can't be used in a commercial building. They don't typically do that for a lot of different reasons. But there's nothing against saying that you can't take a load center from your supply house that say is a BR load center or a CH load center from Eaton and install it in a commercial building. You can do that. The amp rating of it and things like that you might need a larger panel board than what we make in load centers. So a load center is a panel board. So if you want to take your marketing hat off and just say you go by the standards, it's listed to the same standard as a panel board. It is a panel board, period. There's nothing special about it other than what we do from a marketing perspective. Same thing goes for an insulated case circuit breaker, right? So you have molded case circuit breakers, insulated case circuit breakers, and power circuit breakers. Insulated case circuit breaker you will not find in any UL standard. An insulated case circuit breaker is a molded case circuit breaker. It's listed to the exact same standard. It's just a more functional device. And I just had this discussion with another individual who sent me a note. We were in a meeting and talking about what you would do for an insulated case versus a power circuit breaker. And I made the statement, I said, I wish the term insulated case circuit breaker did not exist, in my opinion. I really do. It's a molded case. It just confuses people. It's like load center. I wish the term load center did not exist. It is a panel board. It's a residential panel board as opposed to an industrial commercial panel board. It's meant for the residential market. But we, for some reason, try to differentiate things with terms, and then they work their way into our vocabulary, and then some people think it's different, but it's not. Insulated case circuit breaker, the discussion around the insulated case circuit breaker was I verbally said I wish it didn't exist, and then I got an email from someone who was on that call and said, hey, you can't say that because an insulated case circuit breaker is different than a molded case circuit breaker. There's more functionality, and it's bridging that gap to a power circuit breaker. And I said, well, we'll use the term miniature circuit breaker in the residential world. There's another term you probably heard, a miniature circuit breaker. What is a miniature circuit breaker? It's a molded case circuit breaker. It's a smaller circuit breaker, and then you take that smaller miniature molded case circuit breaker and you make a bigger molded case circuit breaker, and it has, with an electronic trip unit, you can have accessories. So there's more things you can do as the circuit breaker gets bigger, and there's more functions and features. Perfectly fine. So the moment we start introducing terms that don't align with standards, it confuses people. So Brian says, I think you said that all molded case circuit breakers have a handle and all breakers with handles are molded case circuit breakers. That is correct. Well, okay. It is correct. It is correct. It's a molded case. All molded case circuit breakers listed to UL 489 that are not insulated case circuit breakers, which, an insulated case breaker is also listed to 489. But when you look at a molded case circuit breaker, if it's got a handle on the front, goes on and off, it's an MCCB, and it's a smaller MCCB. If you've got a push button on the front, it could be an insulated case or it could be a power circuit breaker. So Ryan, yeah, and do you want to know why that is important? I'll tell you why that's important. Because for the electrical worker, I got drawers now. I don't have to walk over there on the floor and grab my book. I can actually just open a drawer and 70E table method for the electrical workers who are using the table method. This is why it is so important for someone to understand the difference between a molded case circuit breaker and an insulated case circuit breaker. and a power circuit breaker in Article 130, 130.8, the 7, 130.7, Table 130.7C15A, arc flash PPE categories for AC systems. They talk about molded case circuit breakers, and they talk about the clearing times. And if you're working downstream of a molded case circuit breaker, you know the clearing times and you can work your way into the tables. The moment it is an insulated case or a power breaker, you're into a heavy PPE. And you need to know that because the reason you've got the insulated case circuit breaker, these are the big boys and girls, right? And you have the power breakers. Why? Because I want to hold those contacts closed long for those fault currents. And that's going to let me selectively coordinate with things downstream. That's going to let big motors run, all that great stuff, or a bunch of motors turn on at the same time. Okay. So that's going to give me my intentional delays further up in the power system. And intentional delays for the electrical worker is ungood. That's a technical term. Correct, Ryan. It's important for 70E, and I know you know that. All right, so molded case circuit breakers. We were talking about load centers, different than panel boards. They're not. Load center is a panel board. Panel board's a load center. Just call them a panel board. Residential panel board, if you want to delineate the two. So load centers are really the term we use for residential panel boards. All right, molded case breakers. Okay, molded case circuit. Now, here's the other aspect that you've got to think about with panel boards. Panel boards come in various shapes and sizes, voltage ratings, ampacity ratings, and if you go to Eaton's Panelboard, I'm going to just call up our Panelboard website. Look at down here. So here's voltages. I've got 240 volts, 125 volt DC, 250, 480. So if I say 480. 480 volt panel boards. I've got a Powerline 4F, which is a fusible panel. Can I put multi-case circuit breakers in there? No. Powerline Expert 3X. Pull this over here. I've got a Powerline Expert 1A. Okay, so now let's take a look at that. Look at that nice little skinny panel board there. Oh, look at this. Retrofit. This is just the interior to our point. Okay, so this is a retrofit lighting and appliance panel board. That's the panel board. So somebody might say, well, wait a second, Tom, that's not a panel board because where's the enclosure? No enclosure in a panel board. You're buying this. That is a retrofit interior. I call it. I think that's what they call it too. Fully rated to 22 KAIC, series rated to 200, 100 to 225 amp continuous rating. That's 480 volts. Includes bolt-on. Look at this. Bolt-on beakers. Yes, beakers. You remember Beaker? Beaker was a Muppet, wasn't he? We bolt him into our panel boards. I've got to send Marcom that one. Flush surface mounted and fully series rated options offers cover. So let's take a look at technical. 480 volts, 100 to 225 amps. There's the PB1 is a good reference for you. Panel board one. That's a good document from NEMA. That's also a free download. I should have put the link to that. There are seismic qualifications, UL67, molded case circuit breakers, and miniature. Look at that. Miniature circuit breakers. What's a miniature circuit breaker? This is what we do to ourselves. Yes, that's exactly right, Don. But here's the thing. And a miniature circuit breaker is not even in the National Electrical Code. So you have to be careful. I could call it a humphalump. I could say I've got a humphalump panel board. I can call it whatever I want, and I can have pictures of it. I could call it a humphalump and a woozle. It's a marketing thing. So unfortunately, in some cases, people think that it's special, or that they're going to look in the National Electrical Code for a miniature circuit breaker. What's a miniature circuit breakers? Are, again, and I've used it earlier, it's a term we use for residential type breakers. They're plug-on breakers, but it's still a UL 489 device. But we dig our own holes, which is okay. I mean, I'm not gonna cry. I might. I don't know. But in any case, it makes our jobs a little bit more complicated if you're into codes and standards. And guys like Don Gannier, thanks for joining, and Ryan Jackson. We've got to learn how to be flexible and maneuver and understand when you hear someone say, "Hey, that's a miniature circuit breaker." Still a UL 489 device. All of the requirements and all of the standards associated with that still apply to it. I will hit fully rated and series rated. Yes, I will. Contact. So now for these devices, if you go to the product support, I just want to try to get. I'm trying to get Panelboards. I'd like to get a picture of it. Panel designated template, panel and switchboard series ratings. There's series ratings. We're going to talk about series ratings. Control. I guess if we go to the catalog, you probably will find it. Enclosed. If I do a Control F, I do enclosed. Or no, retrofit. Retrofit panel board. Look at that. Bam. There it is. Whoa. There's the retrofit panel board, and see how it has we even build in the dead front for you and all that good stuff. So that is, I'm saying, you may get something like that in the mail or on a job site and say this isn't a panel board, but it is. So in any case, shows you all the different sizes and everything else associated with it. So there's a whole wealth of information there. Panel boards vary from single to three phase. So here, yeah, and this is why I went down this road. If you think about a panel board, remember that a panel board, let's go back up here and go to a Powerline 1X. All right, so a Powerline 1X. So if you look at this panel board, look what it says. You have main breaker right here, right? So this is giving you a list of all of the circuit breakers that can be put in that main position within that panel board, within this specific panel board. So I can put a BAB, 100 amp BAB breaker. I can put a 100 amp PDG2, a 100 amp PDD2. I can put a 225 amp PDD2, a 400 amp PDD3, a 400 amp LHH. Okay, so these are the main breakers that I can put in that spot. If it's not on that list, you can't put it there. It also tells us, look at this one right above my head. That is a branch circuit breaker. So these are all of the branch circuit breakers that can be placed in this specific panel board. Now, I'm going to go back up to the top, and I'm going to pick a Powerline 3E. All right, so now let's take a look at a Powerline 3E. I don't care what manufacturer you're dealing with. You have the same type of things going on. Here's a Powerline 3E, main lug only, so it tells you without a breaker. Now look, I can't put a BAB in this as a main breaker. I can't put a BAB breaker in here. I can put an LHH. There's the LHH. But you're not going to see the exact same breakers as a main as you saw on the previous panel board. And the branch breakers, where's my branch? So there's my main breakers. Powerline 3E, fully rated, bolt-on branch, box size, instructions, fronts. There's my sizing. There's my 3E branch There it is. 3E branch breakers. I can put an EGB, EGS, or an EGH, and that's it. So all I can put on this in this panel are those 3 breakers in my branch locations. So why would I be using something that's not Eaton? That's exactly, Ryan. Gosh, I don't know why people do stuff like that. So you're the man. Anyway, so you've got to be sure that when you're doing your design, if you want to use this panel board for some reason, you've got to figure out what breakers go in it. And usually we don't talk about the panel board. So the way I always look at things, I would engineer a system around the overcurrent protective devices, the available fault currents. I pick my circuit breakers and my fuses based upon my my functionality that I want, my selectivity that I want, the protection levels that I want, and then I figure out, I call it wrapping steel around the breakers. But it's important to understand that you may pick a main breaker and a feeder breaker that won't fit in the same panel board. You may pick a main circuit breaker that won't fit as a main in the panel board that you're thinking about. So, and there might be other options. So that's when you start fine tuning your design. But in any case, be mindful of that. All right, so we talked about that panel boards can have molded case circuit breakers. It can have fuses. You're not going to put an insulated case circuit breaker or a power circuit breaker in a panel board. Ain't gonna happen. Okay, take it to the bank. It ain't gonna happen. They're only for molded case circuit breakers or fuses, and you might have somebody call a molded case circuit breaker a miniature circuit breaker. It's the same doggone thing, okay? Still a molded case circuit breaker. Single phase to 3-phase. So we said there are a lot of different options. You'll have single phase panel boards. You'll have stuff that's only 120, 240. You'll have stuff that's 208, 3-phase, 480, 208, all that good stuff. And you might say, well, what can I use a 480 volt panel board in a single phase application? You could. The rated voltage being, it's an overkill. You'd have to really follow the, you have to make sure you wire it up correctly. I don't know if there's anything in the National Electrical Code that would say you can't do that. It's rated correctly for voltage, as long as you wire it correctly. I wouldn't recommend it. Why is it called a lighting panel? Good question, Chad. We don't have lighting panels. Remember, and I used to struggle with this on way back in the day. I was working my first, before Eaton, I worked for a consulting engineering firm, which was Gilbert Commonwealth, which is now Parsons Power. And I can remember looking at a schedule, and it said a lighting panel board, right? And it had lighting circuits on it, but it also had receptacle circuits on it, and there were also some heater elements on it. And I'm like, I raised it to the PE I was working under. I said, "Hey guys, we got a problem." I said, "Oh, we got a big problem. We got a ton of panels in this job that are feeding. They're lighting panels and they're feeding receptacles. We're gonna have to fix that." He just got a chuckle out of it. We call them lighting panel boards because they provide power to lighting. I mean, you could call it a receptacle panel board. You can call it we call things an emergency panel board because everything on it are emergency circuits. These are terms we give to those objects, not terms you will find in a code or a standard. Now, a lighting panel used to be in there, and Don Gannier pointed it out. They got rid of lighting and appliance panel boards number of cycles ago. I can't remember exactly when, but these are terms we give them. George says, and in IEC world, that's your international, they have ACB, MCCB, and MCB terminology. The terminology is confusing. It really, and I don't. Some of it we inflict on ourselves, right? I don't know. It is what it is, and we just have to navigate those words, those areas. George, got to just navigate them, buddy. You know, gotta be agile, like a sport, like an athlete, right? You're running down the road and you're carrying panel boards to the job site, and someone throws a load center term at you. And what do? You duck, you dodge, you move, you pick up that what you know is a panel board, and you keep running. Don't stop, scratch your head, and analyze it. Not worth your time. So panel boards will only go up to a certain ampere rating, up to 1200 amps. Now that's not the short circuit current rating. That is the ampere rating for that panel board. And there's your residential panel load center is a panel board. Is a panel board. Oh, hey, Ryan, by the way, Ryan Jackson, I saw your layout, buddy. You've got a nice chair. Let me know where you got your chair. I'm in the market to buy a new chair. This is a $29.95 Office Max special. It is the most uncomfortable thing I have ever sat in. Yours looked like it had mesh. I'd love to know where you got your chair and what model and number is, because probably this weekend I'm going to go buy a chair. All right, suitable for use as service equipment, suitable only for use as service equipment. 250.24. Now we're getting into, so we know the panel board's that insert. We know the enclosure is what we wrap around it. We know they're listed to 2 different standards. We know, Joe, yeah, you know, Joe, I would make my own chair, but I'm just not good with plastics, so I don't know. So we wrap. We know that the. Oh, great! Send me a link, buddy. So we know that a panel board is that enclosure. We know that they're listed to 2 different standards. We know we put circuit breakers and fuses in panel boards. Now, let's talk about the grounding and bonding within a panel board. I had. I don't know if. Let me double check something. Move you over there. No, I don't. So let me do this. I'm going to call up a different presentation that I have. That and it's actually a presentation that I made for transfer switches and generators, because there's always a question about separately derived systems and all that good stuff. But I have some slides that are kind of cool. Yeah, here we go. That help us understand service entrance type of installations. Transfer switches. Now, I've got to just talk about the bonding. So this is my, oh crap. I got to go, hold on. Oh, I've got to find the right slide. I went all the ways to the beginning and I didn't mean to do that. I took that picture from my dashboard, my truck, but I was stopped. Where is that diagram? All right. I know it's in here. Oop, that's not it. There is. I wonder if you hide a slide, will it not show up? I think that's what happened. I think I hid that slide and it's not showing up because I know it's in here. All right, so the bonding, if you think about what's important at the service equipment, there it is, not hidden. All right. So let me get myself out of the picture here. All right, so whenever you think about a service entrance installation, you have the neutral bar on one side and you have the grounding bar on another. Now, Don Gannier and Ryan Jackson, don't criticize me for my great graphics. I don't have an artist like you guys do. So I have the white bar is my neutral bar, and my blue bar, which should be a green bar, is my grounding bar. And there's a main bonding jumper. When you look at service entrance installations, there's a physical jumper that goes between these two that should combine those together and bond them together. And when you have something that is suitable only for use as service equipment, it will have that strap installed from the factory. If you have something that is suitable for use, not only for use as service equipment, I will throw a little bag of goodies inside the box that you could install if you want to make it service entrance equipment. Because what you're going to be doing is bonding these two together in that enclosure. You can't use the back pan as that bond. And if you go to 250.20 something, 250.28, the main bonding jumper and system bonding jumper. This, when you go from that neutral bar to the equipment grounding bar, that is your main bonding jumper. And this will tell you what the material of it can be. If, for example, you took that out, or my factory forgot to put it in, don't fabricate your own. Just don't do it. You'll have a lot of questions. How do you size it? There's a lot of different questions about fabricating your own when it is a part of my assembly that I ship. You removed it. Remember, this is suitable only for use as service equipment. If you bought that and said, "Dadgummit, I should have not purchased that suitable for use only as service equipment, so I'm going to just remove the main bonding jumper," that would be ungood. You're modifying that equipment. And the reason, thanks, Don. Don says lighting and appliance panel boards. Yes, in the 2005, and I believe I recall it was the 2008 code that got rid of the 42 circuit. That's the key. That was the key change. We got rid of the 42 circuit rule, and then we also got rid of that terminology of a lighting and an appliance panel board. And I believe that was the 2008 code. Don Gannier, lucky we have him on this call. So, simply removing that bonding jumper is not going to get you what you need to get, because especially if you're going to use it as a sub panel. And here's why. That bond, this blue bar, which is my grounding bar, probably is not going to have I'm sorry, not that one, the neutral bar over there. That neutral bar is probably not going to have a little piece of plastic in there that's insulating it from the enclosure. When you go downstream in your power distribution system, that you've got to isolate that neutral. You can't have it grounded. You can't bond it to the enclosure. So we put a little, I think in our panel boards are the little white piece of insulating plastic that goes in between that bar and our enclosure to insulate it from that enclosure. In some cases, the metal bar will be a part of a plastic piece. And I've got one in that room over there, but I'm not going to go get it. That insulates it from the enclosure. And that's important. You can't have your neutrals grounded downstream, right? So just removing that main bonding jumper does not automatically make it a sub panel that you can use downstream. There's another term. Where in the code do we call a sub panel? We don't. It's a panel board. But it's a panel board that's not a service entrance. Now watch, Don will go, oh, Tom, that's in 408 dot blah, blah, blah. 250.102. Let's look at your question on 250.102. I got to shave my mustache. It's tickling my nose. So this is this is for your grounded conductor, your main bonding jumper, your system bonding jumper, your supply side. So this is what we use to size those. Now, you could say, I'm going to fabricate my own, and I'm going to size it per this. Because Tom didn't ship his, I'm just going to put it in there. Here's the problem with that. Might you put the right size? Sure. But now you have a product in the field that you're going to bond these two together with, and it's not listed that way. If it's not listed as suitable for use or suitable for use only as service equipment, and you just took a regular panel board and now you're going to make it a service panel board, now you are modifying a UL listed product, which if you did follow this correctly and you got a field evaluation and they looked at all the different parts and pieces associated with this panel board, you may get an inspector to say, okay, I'll okay that, but it's really easier just to buy the right product for the job. All right. If you're fabricating your own enclosures and you're doing your own equipment or whatnot, or for some reason you need to fabricate a supply side bonding jumper or a main bonding jumper, this is the table that helps you understand how to size that conductor. But again, if you start modifying the enclosure, then it's questionable. Okay, I've had some inspectors where, so even if you size it correctly, 230.66 requires it to be marked suitable for use, right? So you're now creating something that is not listed, or you're modifying it. Now, I have seen cases where we've shipped a product and I forgot to put the main bonding jumper in the box. And the inspector called it out, said, hey, you know what, you have to install your main bonding jumper. Or maybe I didn't forget. Maybe I did, but for the most part, it's usually in the dumpster, right? And hey, Robert, good to see you, brother. So the inspector, I'd get a phone call and they'd say, hey, this guy's going to fabricate his own. He doesn't feel comfortable with that. I didn't feel comfortable with that. What am I going to say, though? It's up to the inspector. And in some cases, the inspector required a field evaluation. For the most part, we can ship those out, those little kits out, those accessories, and say, hey, I know you probably threw it in the garbage. That's fine. We'll get you another one. As long as the equipment is labeled suitable for use as, then I know that kit. I can send you the part. You can order the part. Supply house might even have a couple on the shelf. Take one out of an existing product. We'll ship it to the supply house. But just be mindful of the listing and violating the listing marks. So 250 and I have a wrong code reference here. And I'm not sure how old this presentation is. It says 2015. So it's on an old version of the code. So the section numbers could have changed. But 250.28 is one code reference that I think you should read with regard to understanding. I think it's 28. Yeah, main bonding jumpers, talks about the material, tells us in there the construction, the main jumper. Yeah, so here we go. It tells you about if you have more than one enclosure, there's a case where you might have to fabricate your own. System bonding jumpers, supply side, and I know maybe it was if the service consists of more than, where is it at? Separately derived system with more than one enclosure, grounding separately derived alternate. In addition to complying with 250.30A, so let's take a look at what 250.30 is. Oh, I'm in 250.30, grounding separately derived alternating current system. In addition to complying with A, which is grounded system, separately derived system that is grounded, etc. Where is my... It says multiple power sources, grounding system, supply side bonding jumper, grounded conductor, grounding electrode conductor, separately derived. It'll tell you that a grounding electrode conductor for a separately derived system shall be sized in accordance with 250.66, which is not the 250.102, because that's a different... You got to size this based on 250.66. It shall be used to connect the grounded conductor of the derived system to the grounding electrode. So you'll notice in this picture, I'm tying the grounding electrode to the grounded bar. The ground, not the grounding bar, but this is the neutral bar, the grounded bar. And it shall be made at the same point on the separately derived system where the system bonding jumper is connected. So here's the thing. We modify them all in time and cutting holes in it. I guess it comes down to installing it according to manufacturer's instructions. Yeah, manufacturer's instructions. That's exactly right. So in this case here, where I have a main bonding jumper, I can land my grounding electrode conductor on either one. I can land the grounding electrode conductor on that neutral, or on that bar. I can land it on either one of these. Why? Because I have a main bonding jumper that's installed that's connecting those two together. If I don't have the main bonding jumper, I cannot land my grounding electrode conductor on that equipment grounding bar, because I can't use the back pan as my connection point. And I don't know if you've ever seen them where that's right, it has to terminate to the grounded terminal bar or bus, but not to the enclosure. So, but if I have that bar in, but if I have my main bonding jumper in, I could put it on either one. But if I don't have the main bonding jumper, it has to land on that neutral bar. And now I could have, for example, just a little post that goes from the neutral bar down to the back pan that bonds it together. But I would have to land my grounding electrode conductor on this neutral bar. That's right. And that's what I'm saying, Ryan. You're right. You cannot land it to the equipment grounding jumper if the main bonding jumper is a green screw. And that's what I'm saying. If you have this scenario where my main bonding jumper on that neutral bar, on this neutral bar here, could be a green screw that just connects that to the back pan, I have to land my grounding electrode conductor on this bar. I cannot land it on the other bar where this one is here, because for me to be able to land it on that equipment grounding bar, I have to have a main bonding jumper that is not that screw, or I've seen them where they're like a little jumper that you bond, like it goes into the hole of the neutral bar and then it bonds to the back pan. There's no main bonding jumper in there. You can't do that. It has to be a main bonding jumper that is a wire, and it's delineated in 250. Ryan, is that 250.28? It's not 250.28. I thought it was 250.30. Separately derived AC system that is grounded shall comply with A1 through A8, except as otherwise permitted. Connected to the equipment carrying metal parts, be connected to equipment grounding conductors, or be reconnected to ground on the load side of the system bonding jumper. Yeah, I'm not going to find it. 250.24. I went the wrong direction. That's it. There we go. Main bonding jumper as a wire or bus bar, 250.24A4. Where the main bonding jumper specified in 250.28 which is the other section that we were just looking at, is a wire or bus bar and is installed from the grounded conductor terminal bar or bus to the equipment grounding terminal bar. So that would be in this picture when I have something like that, where I have that main bonding jumper that is a wire or bus bar. The grounding electrode conductor shall be permitted to be connected to the equipment grounding terminal bar or bus to which the main bonding jumper is connected. So that's the only time that I can put my grounding electrode conductor on that equipment grounding bar over there on the other side. All right. So be mindful of that. If it's that green screw, you can't. So thanks, Ryan, for the code reference. I don't know why I was looking in 250.30, but I was. And I think it was because of I got that 250.30A5, which I don't even think is grounding electrode conductor, single separately derived system. So anyway. Yeah, and there's the so that's when I have that green screw that's connecting these two together. I have to land it there. I'm not allowed to land it on the other side. So that's basically what we're talking about there. So be mindful that you will have a panel board that is suitable for use as service equipment, which means you would have to install some jumpers, bonding and whatnot, or maybe I think what I've seen is those are the ones that have that green screw when you just screw in the green screw and now it's service equipment, or you screw it out, now it's not, or you put that little jumper in. It doesn't have a main bonding strap or anything like that. Suitable only for use as service equipment. Will have that bonding strap shipped from the factory installed. There, 250.24. 250.24 is right there. So 250.24, I put it there, and I gotta love it. I gotta love it. I don't read my own slides. All right, so be mindful that there are different panel boards that go up to 1200 amps, and they'll have three-phase, single-phase. And not every breaker fits in every panel board, etc. So here's some examples. This is a 240 volt maximum power line 1A. 600 amp maximum panel lug, 400 amp main breaker, 100 amp max branch. I got bolt-on breakers only. You're not going to have the plug on. Fully rated or series rated. So, you know what? Let's talk about that. Fully rated versus series rated. Question came in, and I am going to talk about it. So let me find my slides. Fully rated versus series rated. All right, so what is series rating? Now, series ratings basically speak to the, you'll see this little, I call it the yellow book that'll be shipped with a panel board or switchboard or whatever. Series ratings, so you got two different things. You've got a short circuit current rating of the equipment, which is not the interrupting rating. So first understand that. When we're talking about panel boards and switchboards, etc., there's a lot of our discussion that will be around the overcurrent devices that are inside, because the overcurrent devices that are inside help us get our ratings, right? It provides protection for the panel board or switchboard or whatever it is. A series rating is all about interrupting ratings of the overcurrent protective devices. So you'll see now they normally will not be in a nice little yellow what do you call it, a little holder like that. Under one wide. There we go. They won't be in a nice what do you call, a nice little holder like you see right there on the screen. It will more than often than not, you will be a what do you call it? It'll be probably inside the equipment or outside the equipment. It'll be somewhere, in a box somewhere, that little sheet. But if your series rating, if you think about what the code says with regard to interrupting ratings, you can have an overcurrent protected device that can stop the flow of fault current by itself up to a certain number. So we have circuit breakers that are rated for 10,000 amp interrupting rating. That means it'll stop the flow of current up to 10,000 amps. If you have an overcurrent protective device that is rated for 10,000 amp interrupting rating and you hit it with 20,000, you could achieve an unintended rapid disassembly in the field. So 110.10 or 110.9 is your interrupting ratings. Just make sure I'm getting my code sections. 110.9 is your interrupting ratings. Am I right? Yes, I am right. Interrupting ratings, 110.9. 110.10 deals with short circuit current ratings, which is different. Okay, a short circuit current rating is, I have a video where I use my example of a weight bench lifter, right? So think about a weightlifter who's going to be bench pressing. The weights that he's bench pressing or she's bench pressing are the magnetic forces of current. And that person, the weightlifter, has to hold it together underneath the pressure of those forces. And I have a spotter to make sure that I don't hurt myself with regard to the amount of weight I'm holding. And the spotter's job is to protect me from the forces and weight of the weights that I'm bench pressing. Well, that same scenario is similar to equipment. The electrical equipment is the weightlifter. The weights are the fault currents passing through the equipment. And the overcurrent protective device is the spotter to make sure that the equipment doesn't fail and, achieve an unintended rapid disassembly. So a short circuit current rating is sometimes referred to, as Robert said, as a withstand rating. Well, we don't use withstand. We've gotten away from that terminology. We call it short circuit current rating. It's the ability of the equipment to withstand the pressures and forces of magnetic forces of current passing through it. An interrupting rating is the ability of an overcurrent protective device to stop the flow of current. A piece of equipment will not have an interrupting rating. It has a short circuit current rating. An overcurrent protective device has an interrupting rating, not a short circuit current rating. Okay? Now, there are two different ways. I can, in a system, make sure that all of my overcurrent protective devices can stop the maximum amount of current that could possibly flow through it. Or I can have a series rated system where both overcurrent protective devices will stop the flow of current working together. Now, in Article 100, interrupting rating is the highest current that an overcurrent device or fuse is rated to safely interrupt. 110.9 tells that's NEC 100, highest current an overcurrent device is rated to safely interrupt. Self-protection rating only. In 110.9, the interrupting tells you that the interrupting rating has to be greater than the available fault current. Okay, and that there's 1910-303B4 out of OSHA tells you that you have to have that. Now, these two videos show you, this is when you exceed the interrupting rating of a fuse. So this is a 10,000 amp interrupting rating fuse and that is a 14,000 amp interrupting rating circuit breaker. Both of those are hit with 50,000 amps, and we call that an unintended rapid disassembly in the field. So what happens in these cases is the 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 overcurrent device is trying to stop the flow of current. And if you think about what the waveform looks like, it's a very rapid rate of rise during a short circuit. The steepness of that first half cycle shows you a very large change in current for a very short period of time. That creates a lot of magnetic forces, and it's very difficult for a breaker not rated to stop that flow of current to do that. And if you exceed the rating of that device, this can happen, right? You've achieved an unintended rapid disassembly in the field. 240.60 and 240.83 tells us that if a breaker or a fuse is not marked with an interrupting rating, these are the minimum values that you use. 10,000 amp for a fuse, 5,000 amp for a circuit breaker. All right, so I'd like to make that a little bit bigger, but that's about as big. Maybe I do this. Nope. Here's what I am going to do. I'm going to try to make this a little bigger by doing this. All right, so I've got 31,400 amps available at this bus. The main overcurrent device is listed to interrupt 65,000 amps of fault current. And all of the overcurrent protected devices downstream can interrupt 65,000 amps of fault current. So everything in this picture, all of these overcurrent devices can interrupt more than the available fault current that they may be called upon to interrupt. 65K is greater than 31,400. That's a fully rated system, because everything in that picture can interrupt the current that it may be called upon to interrupt. Get that on there. So all of those are 65K. Now, I'm showing another picture here where my main breaker has a 65 or fuse. So that main device could be a breaker or a fuse. But that device is rated to interrupt 65,000 amps. But the downstream circuit breakers are rated only for 10,000 amp interrupting rating, yet they could see 31,400. And you say, this is what we would call a series rated system to 65K, because that upstream overcurrent device and the downstream overcurrent device both act to stop the flow of current. And they'll probably, well, they will, for those high fault currents, they're both going to open, because that's how they get it done. They divide and conquer. Now, the reason I went from showing just the boxes downstream to an actual breaker downstream is because you will never see a fuse downstream in a series rated system. Fuses can't protect fuses, and breakers can't protect fuses. If you have a 10,000 amp interrupting rated fuse, you can't put a breaker or another fuse upstream to increase the interrupting rating of the downstream fuse, period. So the only time you'll have a series rated system is when there's a breaker downstream and a fuse or a circuit breaker upstream. But what happens here is both of those devices will open to stop the flow of current. We test both of these devices in series with each other. We put current through both of those devices in series, and up to 65,000 amps, neither of them can be damaged. They have to be able to safely interrupt that 65,000 amps, even though the downstream breaker is 10,000 amps interrupting rating. Okay, so that's a series rated system. And why is it important? How does it relate to a panel board? In a panel board, the short circuit current rating is going to be dependent upon the lowest interrupting capability of the current overcurrent protected devices inside. So if I have a series rated system where I have a 65,000 amp interrupting rated main breaker and I have a 10K branch breakers, I'm going to label this piece of equipment as a series rated system per 240 and the marking requirements in 110. And I'm going to say, this is, and I'm going to have that little yellow book to prove to the inspector that, look, Eaton tested that upstream breaker with this downstream breaker, or that upstream fuse with this downstream fuse up to 65,000 amps or 100,000 amps or 200,000 amps, depending upon the application and the test results. And they were tested in a lab. And that's how they are able to get a 65,000 amp interrupting rating, which will dictate the short circuit current rating of the panel board. So 240.86 is where you'll find the requirements in the code for Article 240. 240.86. You don't look for 240.86 in Article 210. It's going to be very hard to find section 240.86 in Article 210. All right, so 240.86 is in Part 7 of circuit breakers. It's not in the fuses. It's in the circuit breaker section. Because why? I'm not going to series rate a fused system. Fuses, for the most part, 200,000 amp interrupting rating. Some fuses have 300,000 amp interrupting rating. 240.86, where the circuit now. So you can read 240.86. I'm not even going to get out in front of this code. You have your code book. I know you do. 240.86 has parent text. It has a section A, B, and C. A is selected under engineering supervision in existing installations. So you're engineering a series rated system. And I'll tell you, you're not going to be able to engineer a series rated system with a molded case circuit breaker downstream. And the reason is because dynamic impedance. If I have a molded case circuit breaker downstream, I have to look at my let through currents. But when we get into series ratings, we're using up, over, and down. Remember we can use up, over, and down. If I have a static device like busway, I can use up, over, and down for the fuse let through curves. And we'll cover that in a different session. I can use up, over, and down to series rate and protect busway. I can't do that with a circuit breaker, because when that fault current, that leading edge of that sine wave starts to go, my downstream device will start to open, which adds impedance, which changes my whole picture of my let through curves. So I can't use up, over, and down when I have a dynamic device downstream. I can use up, over, and down to provide a short circuit current rating for, say, busway or others. George says, is the fully rated panel just coming as 3-phase 3-wire and series rated 3-phase 4-wire? No, George, a series rated panel is going to be based on these overcurrent protected devices. You're going to be using that little book. It doesn't have to do with how many wires you have. It doesn't have to do whether it's a 3-phase 4-wire, a 3-phase 3-wire, if it's a delta system or whatever. It's all about breakers or fuses and breakers working together to stop the flow of current, and they'll be listed that way. You have tested combinations. So this is your engineered series. Again, this is your, if my fault, I'm not even going to get into this. That's a whole nother conversation. Our tested combination pairs are right here, panel boards and switchboards. series rating information manual. It's a little yellow book that we put in with all of our panels. You can download this off of the UL website. You can download it off of our website. So George is saying, in a series rated, the upstream breaker works as a backup protection, if I understand that correctly. So I wouldn't look at it as a backup. What I would say, George, is that the upstream breaker and the downstream breaker both work to interrupt and stop the flow of current. Because remember, it's not the upstream breaker you're worried about. It's the downstream breaker that's only rated for 10,000 amps of interrupting current. I've got 30,000 amps that it could be called on to stop the flow, to stop from flowing. 30,000 is greater than the 10,000. So I would expect that if I just had that 10,000 amp breaker and I put 30,000 amps, we saw the videos of what could happen. But the upstream breaker is going to start opening and the downstream breaker is going to start opening, and together they stop the flow of current. And I would say you could look at it, George, as the upstream breaker is operating so fast and is only letting so much energy through. The downstream circuit breaker does not see the full sine wave of the current that's passing through both of them. So hopefully that helps you understand that they are both working in tandem to get it done. Okay? All right, Chad Roberts, thanks for the feedback, buddy. Now, that's the little yellow book that we put out there, and yeah, you know, we sometimes put it on the equipment. So here's an example of what you might see. So what you'll see on the far over there, the main breaker maximum amp is 100 amps, and you'll see the interrupting ratings are across the top there. I have 18, 22, 42, 65. So it says that the main devices are shaded. So if you look, this is 100 amp. So that first row is 100 amp main breaker. The very first column for 18,000 amps of interrupting current is the EHD, our EHD as in David, circuit breaker. So it would be an EHD 100 amp circuit breaker as the upstream device. The downstream device can be a BA, a BAB. These are all catalog numbers. A BRP, an HQP, a QBGF. That's a bolt-on ground fault. A QBAF is a bolt-on arc fault. We tested those pairs of breakers up to 18,000 amps, and they will all safely interrupt 18,000 amps. The BAB breaker is only listed to interrupt 10,000 amps. If I put a QBHW upstream, HW is for higher, the H is your higher interrupting capacity, 22K. That same BAB breaker downstream, which is 10K, can now, those two together, can stop the flow of 22,000 amps. And then we go to 65,000 amps. Now I'm into a GHB circuit breaker, upstream of a little bit more. Even the QBHW, which is only good for 22K, is now a downstream breaker of the GHB or the GB breaker, and those can interrupt up to 65,000 amps, and it goes up to 200,000 amps. So that's how you read these tables, and it'll get sophisticated. So, Chad, if you don't have that yellow book, that doesn't mean that you don't have series ratings. It just means that what you have to do is go either to our website and download the document. UL has a site where you can look for the series ratings on their website for our products as well. Our little yellow book that we ship with it is just to help make your life easier. I've always asked the product line to make a tool for us, but we don't have a tool. We have to go by the book. But this book is you know, if you don't have that yellow book, download it from the website, because if I have a GHB upstream of a BAB breaker, they're going to be able to interrupt up to 65,000 amps. And you got to follow the rules in 24086, but they're tested that way. All right. So upstream and downstream. Now, C is what a lot of people miss. George, they miss C, motor contribution. Series rated systems aren't your, why do we do a series rated system? We do series rated systems because I don't want to buy a 65K circuit breaker downstream. I only want to buy a 10K breaker. Why? Because a 10K breaker is less expensive than a 65K breaker. So I'll put together these two devices to say, look, I don't have to pay for the 65K, a fully rated system. I'm just going to series rate it. I have a 10K breaker downstream of a 65K breaker. Based upon those tables, they'll both interrupt, and then my short circuit current rating of my panel board now is higher at 65K, and I only bought 10K breakers. Everything is hunky-dory until you start adding motor contribution downstream. Now think about how we test. So there is my 65K upstream and my 10K downstream. All the same fault current flows through both of those circuit breakers, and that's how I tested in a lab. I put them in a lab. I put both of them in series. UL 489 tells me the length of conductors to use, and I'll shoot current through that and watch them both open. Now, when you start adding motors downstream, now you're getting into my upstream breaker will see less current than the downstream breaker. I don't test them that way. I test where all of the current flows in the upstream breaker and the downstream breaker. The moment the downstream breaker starts seeing more current because of motor contribution, now you're outside of how I tested it, and the downstream device is calling on more current than the upstream, so it's outside of my testing parameters. What the book tells us in C, and there was some clarity added in the 2020 cycle because of the efforts of Jim Dorsey, God rest his soul, great guy, loved him dearly. He passed away last year, but he instituted and he put some public inputs in to try to again provide clarity, because he was an electrical inspector in Colorado, and he always saw people miss this detail. The downstream motor contribution, the sum of the motor full load currents cannot exceed 1% of the interrupting rating of the lower rated circuit breaker. 1% of 10,000 amps. In light commercial applications, residential, you're not going to see a problem with it. You get into, and I remember doing a presentation in Alabama on this, and I talked about this motor contribution, and I educated people on this C, 240.86C, and I had a gentleman come up to me after the presentation. He said, I think I have a problem. And I was like, well, what's the problem? And he says, I have commercial applications where I've got motor loads, and I've never looked at C. And my comment to him, I said, well, look, you might not have a problem. Just, add up to motor loads, which may not be all that much in some of these applications. And he says, I design car washing stations. And he says, we are all motors. And he series rated everything. His designs didn't incorporate this, and that was a problem. He had to go back and fix. He fully rated system. Once you have a lot of motors, you got to pay attention to the details. Series rated systems are almost mandatory in townhouses around it. A panel full of 22K AFCIs is pretty tough to swallow. Yeah, Ryan, but again, the motor contribution in those townhouses, you're not going to exceed the 1%. So you don't have enough motor load. Where you run into possibilities of having a problem with 240/86, industrials. Your heavy industrials, very rare will I see an application in a heavy industrial where the motor loads will be less than 1%. So I don't even like to say very rare or quite often. It'll vary by application. It'll vary by panel board. Depends on what is downstream of that panel board, right? What am I closing my book for? All right. So that is all I have to say about this. So hopefully that helps you with series ratings. All right. So now let's think about where we're at in our discussion. We talked about the short circuit current rating of a piece of equipment, right? The short circuit current rating of a panel board is going to be dependent upon the interrupting ratings. Now, here's the other thing. Regardless of whether or not you have a series rating, if you have a fully rated system and the panel board is, say you have all 22K breakers in there, you replace one of those circuit breakers with a 10K breaker, the short circuit current rating of that panel board is now 10K. So it's very important that when you replace a circuit breaker in a panel board, you're very mindful of what the interrupting rating is and what the short circuit current rating is supposed to be for that panel board. You replace a circuit breaker of a lower interrupting rating, you could jeopardize the short circuit current rating of the equipment. If it's a series rated system and you put the wrong circuit breaker that's not a part of that little yellow book or the series rated system, it's not one of those listed downstream devices, or if you replace the upstream device and it's not the right upstream device, your series rated system is now compromised. That's why there's labeling requirements in the code to help you get that right. All right, so I was going through the short circuit current rating. This is the retrofit interior. You'll see there up there at the top, right up here at the top, that is that's the listing. So that's the listing for the panel board. Remember I was telling you that a panel board, don't look at the enclosure listing. You have to look at the panel board listing. There's your listing for this panel board. This panel board is a retrofit interior for an existing installation. It's listed that way. You'll notice that it's got all of these little, possible adjustments. You've got this here, all of these different, this is an adjustable plate that can be moved in and out, up and down, all this good stuff. You'll notice that the bar on the bottom, there's your grounding bar. It's a part of this. The neutral bar is all a part of this. Why? Because the way this is listed, and the nice thing about this, if you're doing a commercial building where you have all of these panel boards with, say, old breakers and you want to update them, because you can't put the new breakers inside of those panel boards. You measure the enclosure. You call your local Eaton sales contact. Tell them how many enclosures you have and their dimensions, and he'll quote you on these interiors. And what this interior does is it lets you take the interior of the existing panel out. You don't have to remove the enclosure. That means you don't have to worry about drywall or plaster. You don't have to possibly damage the existing conductors that are in that enclosure. You move them out of the way. You put this panel board retrofit interior inside, put your breakers on, land all your conductors, and you've updated that application to the latest piece of equipment that can take the latest circuit breakers and all that jazz. That's a great solution if you think about it. For an existing, you don't have to bring any other trades in to do drywall or plaster. The speed and getting it done is really fast. It's a listed product, so it's listed for that. The only thing you'll have to do up front is get the dimensions to make sure we get you the right interiors, because it's about bending radiuses and heat and things like that. So this type of solution here could be a godsend if you have an existing installation that you need to update. So be mindful of this solution that's available. All right, 649. SCCR, that's only 10,000 amp short circuit current rating. Yes, Chad, that interior, I don't care who made the enclosure. You can take whose ever panel board that's inside that enclosure out and put this in, because the box, whether, it could be a Hoffman enclosure, it could be a GE enclosure, a Square D enclosure, a Siemens enclosure. It's just a box. This puts you in there. 408.8a requires a field evaluation of such a panel board. If the fault current exceeds 10,000 amps, this will almost certainly change in 2023. Absolutely. So I'm trying to think. There was something else I wanted to say about that. I've had some inspectors question this, and so what we've done in the past, especially when this was a new product, what we did was we provided the instructions, helped the inspector know, and then we didn't have to do field evaluations because it's a listed product. And this product is, again, you're going to be at less than 10,000 amp short circuit current rating. So you're not going to apply this at greater than 10,000 amps. So you because it's a listed product, because you're installing it, per the manufacturer's instructions as a listed product, it does not require a field evaluation. And again, if you're applying this product above 10,000 amps, you're outside of its rating. So this is only listed for 10,000 amp short circuit current rating. All right. Yes, we have a new cover, and I call it the booger cover because it gives you a little fatter lip on either side, and it will go over front, and it has a dead front, which is why you have front, so that all you need is the enclosure. Yeah. Good question, Chad. Now switchboards are different. Right now, here's the thing with a switchboard. A switchboard is a large single panel frame or assembly of panels which are mounted on the face, back, or both switches, overcurrent, etc. Accessible from the rear. They could be accessible from the rear. So switchboards it's a bigger assembly. I'm going to be able to put insulated case circuit breakers in switchgear. I can't put power circuit breakers in a switchboard. I can put an insulated case circuit breaker in a switchboard. I can put molded case circuit breakers in a switchboard. I can put a transformer in a switchboard. I can put panel boards, multiple panel boards, in a switchboard. So here's an example of a switchboard. And what you'll see now in this case here, actually, I've got a better picture. Let me show you something. Let me show you a switchboard. It's in our experience center. So if I go to PSEC, I go to images, not picture library. There we go, picture library. And I'm gonna go to PSEC, the power system experience center is, I think, where it's at. I know I've got a photo of a switchboard somewhere in here. My computer is like, I thought it was there. All right, well, I know I had a switchboard. Got my Power Systems Experience Center switchboard in here somewhere. But I can have a transformer inside of a switchboard. And what they call those are, boy, I wish I could find it very fast. You know what you're supposed to have is you're supposed to have things cataloged on your hard drive, but you don't. Oh, here we go. Yeah, we're getting close. I'm getting closer, not close. Anyway, can't find my photo. So we could take panel boards in there, multiple panel boards. We could put everything in a self-contained type of an assembly, so that when it hits the job site, and we made those, we made that type of a solution. I believe it was for Walmart's, where we can put we got a small footprint. You have the transformer in there. You have your panel boards in there. You have your main breaker, which is your insulated case circuit breaker, and everything is in one self-contained piece of equipment that that's all in this piece of equipment here. So I can have my all of my controls and whatnot. So it really helps exemplify. I mean, it demonstrates that a switchboard, which we had this discussion if you were on our Tuesday call with the qualified individual, the qualified person. Switchboards can have a lot of stuff in them, and from a qualification perspective, to say, hey, I want training on switchboards is one thing, but to say, hey, I want training on a switchboard that I have in my facility is something different, because of all of the different things that I could possibly put in a switchboard. Panel boards are much simpler in an application perspective. I'm not going to find that photo, but in any case, so you have your power line C, UL 891 is the standard for a switchboard, and then you get into switch gear, UL 1558. Your switchboards are going to be UL 891s. Your switch gear, UL 1558 switch gear. And it just gets more complicated and complex, and you can put larger overcurrent protective devices in there, bigger breakers that can hold those contacts closed for longer periods of time. When you're getting into a switchboard, you're getting closer to the utility, further up in the power distribution system. A big difference between a panel board and a switchboard. You can have multi-case circuit breakers in there, insulated case circuit breakers in there. You can put a whole panel board. You also make MCCs with transformers, absolutely, and motor control centers can have a transfer switch in there. There's so many things you can do when you start getting out of the world of a panel board. You can put meters in panel boards. In fact, there's a whole section in the back for metering. In 408, if you look at 408 in the National Electrical Code, it'll tell you some of the things that you can do with regard to panel boards as part 3 in 408. You have your overcurrent protection. You've got you tell you the orientation, whether or not you can put it in face up, and the 2023 code cycle says you can't put it face down either. You can't put it on the ceiling looking down. You can't put it on the ground looking up, or in another piece of equipment looking up. Supplied through transformers, snap-on switches, delta breakers, enclosures. You have to have the right enclosure for the environment. What else is in here? Yep, and then you've got your metering and whatnot, power monitoring and energy management equipment. So in switchboards and switchgear, there's a 408.23 talks about power monitoring and energy management equipment. Another article you can't forget about is 312. 312 talks about cabinets, cutout boxes, meter sockets, and enclosures. So remember, the panel board is what's inside. The enclosure is a 312 product, Article 312 of the National Electrical Code. So don't forget about your Article 312 requirements. And in 312, they'll talk about the bending radiuses. They'll talk about power monitoring and energy management systems, equipment. The wiring space for enclosures for switches and overcurrent devices shall be permitted to contain power monitoring or energy management equipment in accordance with 312.8B1 through B3. Identified. The power monitoring or energy management equipment shall be identified as a field installable accessory as part of the listed equipment, or is a listed kit evaluated for field installation in switch or overcurrent device enclosures. So 408 has the panel board requirements. 312 has the enclosure requirements. So you can't forget about 312. If you're dealing with a panel board, and this is another critical reason why it's important to understand, the panel board is just that interior. It's not the enclosure. 312 also applies to that same enclosed panel board because there is an enclosure with it. So don't forget about reading through 312, Article 312, which is titled Cabinets, Cutout Boxes, and Meter Socket Enclosures. Fully rated, George, good point. You're not going to have a series rated. Series rated does not mean selective coordination. So coordination and protect better for selectively and coordinated protection. You're going to have a fully rated system in a selectively coordinated system. Because if I'm going to tell you that downstream breaker is going to open and the upstream device is going to open to clear that fault, that's the opposite of what selective coordination is. So be mindful, if you have a selectively coordinated system, you're buying a fully rated system. All right? So don't forget about 312. What else? Switchboards, okay, 891 switchboards, all that good stuff, assembly standards, those are all, there we go, this is the picture I was looking for. Look at this. This is a switchboard. You see this right here, this enclosure right here. There's a transformer in there. There's a panel board up here. There's a panel board over there. There is a panel board right above my head, right behind my head. That's a panel board. So you've got a switchboard with panel boards installed. You've got a transformer in here. You've got metering in here. This is a complicated installation. I put some IR windows for us. Got to think about, from an arc flash perspective, vertical bus versus horizontal bus. Barriers. It's complex. It's complicated. So these are your switchboards. So the big difference. So here's bottom line is, you pick your overcurrent protective devices for a power system based upon your selective coordination needs, like George pointed out. And then you try to figure out what steel you're going to wrap around it. And that's an art form in itself, because you've got to think about, some breakers can go into the branch feeders, some breakers can fit in the main, some breakers can feed through on the bottom of the panel. Traditional 891, 3 cycles, short circuit test, 3 cycles. If you are in here's another gotcha on some of this stuff. If you're in a selectively coordinated system and you're putting intentional delays, if you're delaying more than 3 cycles upstream to this panel board, now you've exceeded how it's listed. Motor control centers, same thing. When you're adding intentional delays upstream, especially in the selectively coordinated world, you've got to be mindful of the equipment bus ratings, or the short circuit current ratings for that equipment. Hybrid design, that's what I was telling you. There's a lot of stuff that can go inside. Draw out. This is a switchboard that has draw out circuit breakers in them. Molded case circuit breakers. So panel boards, and then you've got your switch gear. So this, I'm just basically getting you up through the power distribution system in the and it is 703. So all right, so what do we so I gave you some references with regard to the panel boards. I gave you some references. I gave you some information from a manufacturer's perspective. Take a look at some of the catalogs that we offer, that helps you understand what breakers can go in which enclosures and what locations. Think about the short circuit current rating of that equipment. Think about the enclosure. Don't forget about Article 312 and the enclosure requirements for the enclosed panel board. You think about the 408 requirements. And remember, in 408, we have to mark enclosed panel boards now with the available fault current, and switchboards and switchgear, so that you can compare the available fault current with the short circuit current ratings. See that? I need my Keith Laughlin thinking pen. What else? short circuit current ratings. We talked about enclosures. Whoa, you know we didn't talk about? We didn't talk about, I'll do it real quick. One of the aspects of a fully rated versus series rated, right? What about 100% rated? What do we mean by 100% rated? And we usually think about it with regard to, see what this pen does for me? It just boom. Well, what do we think about when we think about a fully rated system or 100% rated means 100% versus 80%? Remember when you do your load calculations, you add the 1.25 onto the whole system. If I'm going to do a fully rated system, 100% rated, meaning a 100 amp breaker can handle 100 amps, not 80% of 100 amps. That whole decision starts when you're doing your load calculations. I'm not doing the 1.25 because I don't need to, because my breakers are going to be 100% rated. But remember that my circuit breaker could be 100% rated, but it's going to be dependent upon the panel board or the switchboard or whatever it is I'm installing it in. So if my panel board is not equipped to handle the 100% rated circuit breaker at 100%, then I can't use it at 100%. It's not as simple as just changing out a panel board, because 100% rated solution is a combination of the overcurrent protective device and the enclosure. So it's 80% versus 100%. All right. So PPT height. All right. So here's what I'm talking about. Those conductors, when I'm sizing those conductors, 80%, UL 489 and UL 98 for switches, they test everything at the 80%. And what am I doing? That I'm worried about heat inside of the enclosure. It's a heat rise test I need to pass. And what I rely on to help get the heat out is copper, is the metal that's in there. So if I have 100% rated, I'll have to have a breaker that is 100% rated, but it will require the enclosure to combine with it to get me to that rating. So if I bought, for example, say it starts with your load calculation. Let's say, for example, I started my load calculation and again, we're in 210.20, overcurrent protection, branch circuit conductors, continuous and non-continuous loads. When we start there, we add that 125%. If I didn't add the 125%, I used 100%. Now I need to pick the right breakers. If I bought equipment and I didn't specify that I need 100% and I got shipped product that can only be used on 80% rated, then I can't just change out the breakers. So look in UL 489 tells us that 100% rated circuit breaker that's marked for use at 100% of its rated current shall be tested as described in 7143. This is right out of UL 489. In the smallest enclosure in which it's intended to be used, right? So that's the enclosure, or it can be done in open air. 100% rated circuit breaker shall be tested in the smallest enclosure or cubicle with which it's intended to be used. The temperature rises where connections are made to external bus bars when bus bars are used or on wiring, can't exceed a certain number, okay? And I need to go to the next slide. Next slide, please. Thanks, Tom. For a 100% rated test, a circuit breaker shall be connected with a copper bus bars. So if I bought an enclosure, a panel board, an enclosed panel board where the panel board had aluminum bus, it's not going to be 100% rated. I'd have to change out the panel board. Why? Because the UL standard tells me it has to be a copper bus bars. Unless the circuit breaker is marked to indicate otherwise, the bus bars shall have a cross section. And now it tells me the size, the cross section of the bus bars. Why? Because I'm worried about heat and the amount of copper that I have in there. Circuit breakers having a frame size 250 amps or greater, or a multi-pole type of ampere rating over 250 volts and intended for continuous operation 100% rating shall be marked suitable for continuous operation at 100% of rating only if used in a circuit breaker enclosure type, catalog number, or in a cubicle space with the specific dimensions. Okay, so if you bought the wrong panel board, some panel boards can't handle 100% rated, so you might have to change out the entire panel board. There's the definition of a current rating. The current ratings of a panel board is a maximum continuous current that can be supplied through the main terminals unless the assembly, including the overcurrent devices, are marked for use at 100% of their current rating. Overcurrent protection devices should not be loaded continuously to more than 80% of their rating. We rely on that more copper to get, or more conductor to get the heat out. Now, this is out of the white book, which is the 100% rated. This is the marking guide. This is in that marking guide for panel boards that I shared with you. That's in that link. A breaker with a frame size 250 amps or more, suitable for use for operation, blah, 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 blah. Okay, so this gives you more. It's just more of the same stuff. Now, this is out of our catalog. And look, this is the circuit breaker selection must be designated as a 100% rated breaker. Now, here's our catalogs. And you'll notice it says CKD has a note 3, 100% rated, but the HKD doesn't have note 3. So if I bought an HKD, not 100% rated. If I bought a CKD, it is 100% rated. If I bought a CHKD, it's 100% rated. Now, look what it says under 3, 100% rated, right? Okay, so that's the breaker. Now, I got to go to the panel. There's my panel board solution. Look at the notes. Requires 100% rated circuit breaker. Requires copper bus. That's based on the standard. And it's not available in type 12, 4, and 4X enclosures. So if you bought a type 4X, 4, or 12 enclosure, you're not going to have a 100% rated solution. Is it true that 400 amps is the lowest ampere you can get with 100% rating? Well, let's go back. Hold on. Based on this, it might be true, Chad. I'm not sure. I'd have to take a look at my catalogs to double check and make sure. But you know, again, this is this breaker can be adjusted from 100 to 400 amps, so it's a 400 amp frame, but I can have a 100 amp circuit, but it could be 100% rated. But it could be that it's under a 400 amp frame. So the enclosure makes a difference. Now look at this one here. So this is all of these are 400 amps, so it's holding true, Chad, holding true. What does this one say? It says 100% rated breaker. Look under 7. 100% rated breaker requires copper bus. K and N frame breakers require density rated copper bus. And again, not available in type 12, 4, and 4X enclosure. So now if you have a K frame or an N frame circuit breaker, you need a density rated copper, but the devil is in the details. Okay, so why are you doing 100% rated? Think about why you're using 100% rated equipment. You're not putting the 1.25 on the load calculation. Why would you not want to do that? You want to use a conductor at its ampere rating. You want to use a smaller conductor for the load. Why would you want to use a smaller conductor for the load? Save money. And when you're starting to do things like that to save money, series ratings, 100% rated versus 80% rated, you are in the world of cross your T's and dot your I's, and don't cross the I and dot your T, because if you screw up, you will be applying the product outside of its rating, and that could be detrimental to the installation. If it's missed in the installation, if it's missed during the inspection, your customer will not see the ramifications of it right away, because we're talking about heat buildup, and damage due to heat buildup is not going to come to fruition until well after the installation has been in practice and in play. All right, so that was another important part. I had my Keith Laughlin thinking pen in my hand, and that's what generated that. And that's what I had on panel boards. all I have to say about that. So Chad and George, thank you. Dawn Gannier, thank you, Dawn, for what you do. And I don't know if we still got Ryan Jackson in the house, but thank you, Joe Bellantoni. You would need to do a cost analysis of the savings of using the smaller conductors. Exactly. Thanks, Chad. You're exactly right, Dawn. You a lot of people will do things thinking they're I do that. I used to. I did it once, trying to save money in a tool. I went to one of those shops that sells those very inexpensive tools, but what are they designed for? You use them once and you throw them away. And if I want a tool in my garage when I'm building my desks and stuff like that, then I'm not going to skimp because I know it's going to be around for a long tool over and over and over and over and over. So me buying a lower cost tool today for a tool that I'm going to use heavily, I'll be buying a tool every so many months. I may have saved money that one time, but I'm going to lose money over the long haul. Same thing in a lot of these applications where we try to save money on an installation. We cross our T's, dot our I's, we get it down, and we realize our time is worth something too. And you probably spent more hours trying to save a few dollars than it's worth. So absolutely be mindful of that. Don't forget www.eaton.com electrical worker training. 10% off if you use the promotional code Eaton Tech Talk. Now that's cool. There is a wealth of stuff. You want to know about Panelboards, you want to know about series ratings, interrupting ratings. We have training classes that they'll come to your job site, they'll come to your site, they can do it virtually, they can get you into our experience center where you can get your hands on equipment. You can ask the right questions to all the right people, and they will do everything they can to help you and get your answers to your tough questions, because these guys have seen it all and heard it all. So don't forget, get that 10% discount and use that code. I told my engineering services guys they're going to star 250 or more. Oh wait, what's that? Okay, 489. Continuous duty only allowed at frame size 250 amps. All right, there you go. Continuous duty only at 250 amp. So 250 amp and above. Good checking. Good chicken, Ryan. Thanks for checking that. Cool. All right. Are we good? I think I'm good. It's 7:17. We went well over. Thanks, George, Chad, Ryan, and Dawn Gannier, James Smith, Joe Bellantoni, Mohammed. Thank you. We even had Nihad on. I know he's still in Egypt. So thanks, everybody, for tuning in and sticking through this tech talk. Appreciate all you do for the electrical industry. So thank you very much. And Tamaki Ono, that's so helpful. Awesome, Tamaki from Japan. Excellent. I love Japan. I was there for a week during a UL, not a UL, it was an IEC standard. And I was in Tokyo. I flew into what's up north, the airport, took something airport, and I took the train down to Tokyo. And Tokyo Station, wow. Here's the thing with Japan, probably China too. If I go to I don't know, if I go to Mexico or whatnot, you can sort of read the words and make things out. Japan, no way, man. I couldn't tell anything. So what I did was, on my phone, I had an app that I could scan the words and read it. So I could read the menus. Some of the best food ever in Japan. So I love Japan. Thank you for so much. Hopefully we get back over there again. I'd love to take my wife, and beautiful country. So I want to go to Europe too. I want to get over to England. I'd love to go to England. So we have our bucket list. For what capacity in amperes? Tomas Martin Peña Silva. For what capacity in amperes is 100% recommended? Tomas, 100% rated. I'm not sure if I know what you mean by capacity. Remember, Ryan and crew pointed out 250 amps and above. Those are where you're going to find your breakers that are rated that way for 100% rating. I wouldn't recommend going for the 100% rating. I just do things like you usually do, unless you're trying to bail yourself out of a problem. But if you're in a problem, then you've got to buy the right equipment. So it all starts with your load calculation. You do your load calculation doing 1.25. If you don't do 1.25, then you're into 100% rated equipment. You got to buy the right breaker, got to buy the right enclosure. All right, guys and gals, thank you. I've got to get out of here, get upstairs, and do some things. Thanks for what you do for the electrical industry and electrical safety. Stay safe. Please stay healthy. I am going to sign out. So until not Tuesday, remember, Tuesdays next week is going to be West Virginia chapter. So you've got to register for that, and $50 if you're an IEI member, $75 if you're not. We're doing 2020 code changes, 8 to 10 in the morning, 5 to 7. So that's going to clobber my Tuesday afternoon. But next Thursday, we'll be back online, and I'll get an agenda out for what we're going to cover. I'm really signing off now. Take care. Thanks. Catch you next week. Right.